Hi, Antonio.
Hey, Monique.
How are you?
Tired.
Way too early sometimes.
I had a hard time getting up this morning. I had a get together with my friends for being the last weekend here, and I stayed up till 1 in the morning.
Oh, wow. Sorry, you're going to be really tired then.
Yeah, but it's okay. It was worth it.
That's awesome. It's good to be with friends, right?
Yeah.
So I don't know. Hopefully other people can join. If not, I guess me and you.
Yeah. Are you recording now? Is that the live thing?
Yes.
Just want to make sure.
Yeah. I just did it before.
Yeah.
I forgot. So.
No, it's fine. So I'm still working on the extension problems. And I have some of it done. I have all of the first part, the graphing part, and I'm on the second one of the second part.
Okay.
So I'm not too
did
far ahead. Okay.
So hopefully I can help.
Okay. I've been trying to, like, they're not hard. It's just I've been putting it off.
Yeah.
And so I just gotta get back into this thing.
Yeah. Let me pull this up.
And I think so. I don't know if you want to go over it. The first two graphing ones.
Yeah, we can see if we kind of got the same answer.
Yeah. So I actually graphed it first. And I figured that it touched the x-axis on 2, 0, and the y-axis on what is that? 6, 0, 6.
-6, right?
Yeah, -6. And then so I'm not sure why I have it on here. I did these yesterday. I'm not sure why. I have the domain as 2, infinity.
I had negative affinity to positive affinity to affinity.
Yeah, that's what I was looking at today. I was looking at it and I thought
I think the range. I think the range is negative infinity to 2 though, because it has that.
Yeah. Yeah, that's what Yeah, I think I don't know what was wrong with me yesterday because I looked at it today and I was like, that's wrong.
You're just tired.
But then I got, for the transformations, I got that it was decreasing, and then it's reflected on the x-axis with no stretch or shrink, and then it goes right 3 and up 2.
Yep, that's what I got too.
Okay.
And then domain was negative affinity to positive affinity, and then range was negative affinity to 2.
Yeah.
Okay.
Yeah, after switching that negative 2, gosh. I think I did the other one okay-ish. Let me see.
The second graph?
Yeah. Actually, I might have not. So I graphed it, and the point where it meets the x is, let me see.
It's like I got a negative 1 point. Oh, I got it. It didn't cross the x-axis.
I have a point. I don't even know what point
I
it
had
is.
y-intercept as 0, negative 1.8.
0, negative 1.8. Oh yeah. Yeah, I got that point. But I got a point on the x-axis too. But I don't know what it is because I just wrote it over here between 25 and 30.
Yeah, I didn't do that part, and I don't know if you need to because it didn't ask for the intercepts.
Yeah, I just to help me graph it. But then I got the domain as -4, comma infinity.
Yes,
And okay, and then the range as -infinity, comma infinity.
Yes.
Okay, and then I got it that it was growing, it was increasing, and there was no reflection over the x-axis, and then it stretches by 2, and it goes left 4 and down 3.
Yep, that's what I got. Cool. And then the next one, I'm just trying to get back in there, was solving, I think, log base 3x equals log base 3 2 minus log base 3x minus 2.
Yeah. So
And I
I
got.
just. Huh?
Oh, go ahead.
Oh, well, I don't know if you did it. And I actually was looking at the next problem and the problem after that. And if you just get rid of the minus, if you subtract things over just to have multiply instead of dividing, it actually makes it a lot better to deal with.
Yeah, because I did since it was negative, I did the dividing. So that makes sense.
Because I just added the log base 3 x minus 2 over. I added it over. And so then you would get, after canceling out all the log base 3's, you would get x times x minus 2 equals 2. And so then after that, you'd just subtract the 2 over, and you'd get x squared minus 2x minus 2 equals 0. And then you just use the quadratic formula.
Yeah.
Or whatever it's called.
Yeah.
I forget the names.
No, you're right. It's quadratic, right?
Yeah. But what did you get?
So they wanted decimal form. So I got 1 plus square root of 3, which was 2.73.
Oh, they did want to. I only got the 1 plus square root of 3.
Oh, it just said be sure to show exact and decimal form of solution.
Oh, I got it.
So I wrote both because I didn't know, but
yeah,
I think this, when I looked at it, was in decimal form when I checked my answers.
Okay.
But 1 plus square root of 3 would get you the same.
Yeah.
Probably. But on the test, if they ask that, you might want to.
Yeah.
Okay, so then.
My calculator's not working with me. Give me fractions. Okay.
Ready to go to the next one?
So I'm on this one. And
okay.
I actually forgot how to. Should we make it to the power of x, or should we just leave it like that?
So what I did was I divided log 5 plus log 7, and I put it over to the other side, and then it left 2x equals log 9 divided by log 5 plus log 7.
Wait, you divided it? Oh, just and left the x's over?
Left the x's over to that side.
All right, I see. Log 5 and log 7.
Yeah, so that makes sense.
So when you're dividing them over, they would just multiply each other on the bottom then?
No, so it's like saying x plus 2. It's just log 5 plus log 7.
Okay.
And then what I did was I put, and then you have to divide by 2 to get the x by itself.
Yeah.
So I think I just did log 9 divided by log 5 plus log 7 in my calculator, and then I divided that by 2 to get x.
Uh-huh. What did
I got, well, if you want to do it since you haven't done that one.
Yeah, I'll do it here quick.
I don't want to just tell you, not that not tell you the answers, but just so you can see the process.
Yeah. No, I'm actually glad you told me because I forgot to divide. That you divide there.
Oh yeah.
I don't like dividing them, but it's just because it's so long to put on the calculator, but I gotta get over it.
Yeah, it really takes a long time. So on this one though, I don't know if there's actually a 2x. This is actually what I want to, because it has 2x's from the logs, but on the answer sheet, it pretty much doubles what the answer I got. So I don't know if if the x's are the same.
Oh.
That's the only thing. Because I got 2x just because there's x before each one, but on the answer key it says the answer is 0.62, which would not having it be 2x but just a 1.
Oh my gosh, this calculator is not cooperating with me. Okay, so I gotta get my other calculator.
Okay.
So let me see. This is what happens when I'm unprepared. Okay. So, did you get when you did that? Did you get 1.5277? Just ran up to 1.53.
Which part?
What you got for X and the final?
I got 0.3100.
Did I plug that in wrong? Let me put it in.
I'm trying to find an example with because I don't know about the x's. If it's supposed to be 2x or just 1x.
If it's 2, then you might need to go into the quadratic formula.
No.
Oh wait, now I got something else. Wow. So now I got 0.309.
Yeah, that's what I got. And then I just rounded.
Okay. I just plugged it in wrong. But you say it doesn't.
So that's what I got because there's 2 x's, right? But when I look at the answer key, it has there wasn't 2 x's. It just had 1 x, so it would be 0.62 instead.
Oh.
So I'm just trying to find an example of. I don't know if the answer key is wrong or kind of like how last week there was one that was wrong, or if we just use that as a 1.
I wonder.
Do you remember seeing anything like this one?
I can't remember. I think we have, but I don't know. Let me check my notes. Let me see what I have in there. Oh, I gotta close this. I was working on I was working on my engineering homework and it's killing me.
You have a lot of math engineering.
Yes. Well, not right now, but I know it will. Right now, I'm just building parts, and it's just learning the program first.
Well,
So that's the biggest issue right now.
yeah, it sounds complicated. I'm not seeing anything in my notes. But it has to make sense because if you have 1x plus 1x, that's 2x, right?
Yeah.
So I feel comfortable doing it that way. Yeah, I'm not seeing anything in my notes that would say differently. So if you see anything. Yeah. Okay, I feel good about that. Because it's not a base or anything. It's an exponent before the log 5, so it has to be 2x.
I wonder. What was? Let's see. Gosh. So I'm actually looking. So I'm looking at the answer, and so it gives you what they get, and they don't have the log 9 over log 5 plus log 7 divided by 2. They don't have the divided by 2 part on that. So I think
But yeah, but do you see what I'm saying? Like that's what I'm saying is that if it didn't have a 2, it would be the right answer. But
yeah.
there's 2 x's in front and they're not bases or anything, so you can't cancel one out. So I think that's wrong on the answer key. So
Yeah.
I think I'll email her about that one because I think it's supposed to be divided by 2.
Yeah, and I don't think we've done any that have something similar like that where you have to add.
Yeah. So I'll email her on that one because I think it's supposed to be 2x.
Yeah.
Mathematically, that makes more sense to me than.
Yeah, because you should be having the 2x because there's 2x's up there.
And it's not like they cancel out because it's in the front. It's just like having like a 2 or a 3 in front. You'd have to take care of those, you know?
And I was actually thinking, if you put the x back into it and just have it to the square root of, or sorry, to the power of x, you'd still have 2x on the power.
Really?
So yeah,
It has
because
to be.
yeah, so there has to be the 2x.
Okay.
So I think they just left it out. So I think we're right on that one.
Okay. And I'll email her and just double check. But math, like just knowing math rules, it doesn't make sense not to have that go away.
Yeah. We're out
Okay.
of paper room.
And then, are you okay to go to the next one?
Yeah.
Just the natural log x minus natural log x plus 1 equals natural log x plus 3 minus natural log x plus 5.
So I was looking at it before we did that one. I was looking at it and I thought it would be so much easier we got rid of that division. And I actually remember doing it on some time ago. And so I just added both of those negatives over to the other side. But I don't know if you did that or if you did the division part of it.
I did the division just because I didn't think about doing the other way. So if you do
Okay.
it that, when you go to the side where you've multiplied them together, let me just make sure that we have the same
Yeah, I'll do it
answer.
here real quick and then I'll
Yeah, just so we can see if we got to the same. I mean, I got the answer right based on the answer key, but
yeah. Let me just real quick. Gosh. Okay. So after doing that, I got x equals 3.
that's what I got.
Is that okay? Is that what it says on the answer?
Yeah.
Okay. So how I guess how easy or complicated is it to do the dividing? I try to avoid it as much as possible because I just don't
I
like.
didn't do this bad. Like, so if you can see, like, can you see that?
Oh, it's not
So I
that
just did it.
bad.
No, and then you just times, like times it across. So it wasn't bad.
Yeah. So
I
with what I did was I don't know if you can. Yeah. So you just kind of add them over and then you just get rid of that natural log or log whenever they're that.
yeah.
And then I don't know, that's just simpler to me because the x squared and the x usually cancel each other out.
Yeah. No, that's good. I'll remember that for the next time because I think it would think it cuts out a step of having to divide it.
Yeah, I don't know. I see all that a huge amount of writing going on. I'd rather not.
I hear you. All right. So then the next one was the -3 times 2 to the x plus 1 plus 4 equals -18. And right away, I took the 4 over to the other side to isolate the other one.
Yeah.
And then I divided by 3 to get the 2x plus 1 by itself.
Hey.
Hey, Matthew. How are you?
Good. How are you doing?
Good. How are you? Oh, sorry. I'm still recovering from lack of sleep.
Yeah. No. This is the morning. I was hoping this would give me enough time to make up for lack of sleep, but apparently I barely woke up about 3 minutes ago. So.
Hey, Monique, on
Yeah.
that, so I divided -3 over, but now I don't know if I might have to change my settings on my.
I just kept it as a fraction until the very end.
Well, that's my question though. So wouldn't you change that to 2 to the power of something?
Well, so then you have 2 to the x plus 1 equals 22 divided by 3.
Uh-huh.
And then
Oh, wait.
it's x plus 1 equals log base 2 of 22 thirds. So you do it. That's just the next step.
Oh, I was thinking having x plus 1 log 2 equals 22 thirds.
Oh, yeah. So the x plus 1 gets put by itself, and then the log base 2 of 22 thirds.
Okay.
And then to get x by itself, you just minus 1 over to the other side.
Oh, I see. Okay.
And then log base 2 to 22 thirds minus 1.
Okay, let me.
What one are you guys on? Are you guys on the second one?
Yeah, so we're on the second extension problem, and then it's the fourth equation under that one.
So did you get 6, lesson 3 and 4, right?
Yeah.
Okay.
Did you get 1.87?
Yeah.
Okay. Is that what? Oh, it is. Okay. Sweet.
All right.
Oh. These next two should be easy, shouldn't they? They're just the formula ones?
Oh, we have one more, though. The 2 to the x equals 3 to the x minus 1.
Dang it, I was so excited. Okay. I'm back on track now. So on this ones, wouldn't you do that, what I was saying before with the x log of 2 would equal x minus 1 log of 3?
So what I did was I took the natural log of each side.
Okay.
And then with the rule where you do, so then it would be x natural log 2 equals natural log 3.
Wait. X minus 1 natural log 3?
Yeah, because that's the exponent.
Oh.
So you put the exponent in front, and then it's the natural log of the number.
So then how would you get rid of the if you subtract x over, you'd get rid of x, wouldn't you? Or
I don't remember what I did. My next line says x natural log 2 equals x natural log 3 minus 1 natural log 3. Oh,
I remember.
I times it into it like I did the distribution. Distributive property.
But you only did it on the on the right side or both sides?
Yeah, just on the one side.
Okay, let me see if I can. So be x ln 3 minus ln 3?
Yeah, x ln 3 minus 1 ln 3.
Okay.
And then I plus the 1 ln 3 over to the other side.
Oh.
I think I may have done some extra steps that weren't needed, but
So then, did you divide the x over or the ln3 first?
I did 1 plus 1 ln3, and then I had x ln2 plus one ln3 equals x ln3, and then I minus. See, I think I did an extra step, but I ended up with 1 natural log 3 equals x natural log 3 minus x natural log 2, and then I divided the natural log 3 minus the natural log 2 back over to the other side to get x by itself.
Okay.
And then I got 2.71
Okay.
for my answer. Want me to show you my paper?
Yeah, I think that might help. Oh, yeah.
So I think I did some extra steps, but it's this one right here.
Okay. I get it.
Does that make sense?
Yeah.
Yeah. I just, gosh.
I think I did an extra few steps, probably weren't needed, but
No, wait, was that what they got?
yeah.
Okay. Okay, so
Did
then,
did that make sense?
Yeah. Okay. Yeah, I confused myself.
Yeah. All right. You guys ready to go to the next ones?
Yeah. So,
these ones are easy because you just plug them into the formula.
It's the expert one, right?
Yeah. No, it's you use both. For the first one, the compounded monthly. So it would be A equals 500 times 1 plus 0.0525 divided by 12 raised to 12 times 10.
Wait, wouldn't you put 50,000 as A on the front?
No, the first one, it says you invest 500 in an account with an interest rate of 5.25% for 10 years. The first question says, how much will you have if you compound monthly?
And then you would do 50,000 and then do it for and make it the negative equation.
No, what I did, you just have to plug it in. You don't even have to change anything.
Well, no, I mean for the next one.
Yeah, but we're doing this first one first.
Yeah, I was just.
Yeah. So 500 times 1 plus, and then that's the rate, the interest rate divided by 12 because you're doing monthly, raised to how many times you're doing, so 12, and then we're doing it for 10 years. And then you just plug it all into your calculator.
So did you get 823.50?
No, I got $844.26. $844.26.
What did I do wrong? Let me see that again. Oh. Wait, I thought you said 0.05 over 12.
0.0525 because it's 5.25% interest.
Yeah, that's what I got wrong there. Okay, so it was the 844.26.
Yeah.
Okay. Yeah, I just missed that part.
Okay. And then the next part is how much will you have if compounded continuously? So then that one is the A equals PERT. So you just again plug it all in. So A equals 500 E raised to the 0.0525 times 10. And you just have to plug that into your calculator too.
E. So the R would be the 12?
No, R is
Or-
the interest rate, so 0.0525. And then T for time is still 10 years, so 10.
So I got I got 845.23.
That's what I got too.
Okay.
Okay, so then the next one is how long will it take for you to have 5,000 or 50,000 if compounded monthly? And this is where you have to plug in the 50,000. So it'd be 50,000 equals 500 times 1 plus 0.0525 divided by 12 raised to 12t, and we're going to solve for t.
Okay.
Yeah.
To get rid of the 12t on the one side, do you multiply it over to the other side as 1 over 12t?
So what I did at first was I divided it by 500 to get the one part by itself.
Yeah.
Did you already do that?
Yeah.
And then it would be 12. So I got 12t equals log base of the 1 plus. I just did it in the calculator and got 1.004375. So that would be your base of 100. Oh yeah, I guess you would just do that. Well, I had to do a base change.
Or you multiply by 100. Oh, never mind. I see
So
what you mean.
that part becomes your base. So then it's 12t equals log base of that 1 plus 0.0525 divided by 12.
Uh-huh.
And then you to get t by itself, you times 1 over 12. And then I did a base change, so I did log of 100 divided by log of the 1.004375. And then plugged it in the calculator and got the time is 87.91 years.
Wait, was it annually or quarterly? Was it
Compounded monthly.
monthly? Okay. Oh, so it'd be 12. Okay, yeah. I was just making sure because I think last one we did. I don't know if we did. I was kind of confused on the whole. How many do you put in on the homework?
So if it's quarterly, it's 4, monthly 12, yearly, if it's not continuous, but you have to put it in the other one. If it's yearly, 365. Those are usually the only 3 that they.
That'll be the only one she'll test us on.
Yeah, well, because usually you're only compounded quarterly, monthly, or daily.
Okay.
But you just divide however, if they did do something weird like that, you just divide it by 12.
Okay.
So did you get T equals 87.91?
Yeah.
Yep.
Okay. All right, so I did that right.
Okay. Ready to go to the next one?
Yeah.
Yeah.
So the half-life of uranium, I guess we could all read that, it's fine. And then part 8 is the sample of radium-226 has a mass of 100 milligrams. Find a formula for the mass of the sample that remains after T years.
Oh,
So-
they just want the formula?
Yeah.
Yeah.
So
So
I
if
use the formula A equals A base 0 raised to the 1/2
Yeah.
pH. If you did it that way, it'd be 100 E raised to the natural log 1/2 divided by
Over
1590
1590 times T.
times T. Is
Yeah.
that what you got?
Yeah, that's what I got.
That
Okay.
makes sense, Antonio?
So you said 100 E net to the power of natural law? Is that what you said?
Yeah, so the half-life would be natural log 1/2 divided by, and it tells us in the first part of the problem that the half-life is 1590. So
Yeah.
natural log 1/2 divided by 1590. That's for the age. And then you times it by T.
H. What is that formula? I don't think I remember that formula.
It's the half-life.
I know you said A.
Radioactive dating.
I don't remember using that one. Huh. AO H times T. Okay. All right. Now I get it.
And then so that was part A. And then part B is find the mass after 1,000 years. And then correct to the nearest milligram. So then all you do is take that formula and you add 1,000 for the T and plug it in your calculator.
Oh, I got an error.
And we'd be solving for Y in this, right?
Yeah.
I got 64.7.
I keep getting an error. I don't know why.
When you're putting it in, are you putting parentheses around?
So I'm putting in 100 times parentheses E to the
And then
it
it has parentheses, and then you have to put another parentheses. I don't know if you can.
times.
So 100 E and then it has two parentheses, ln 0.5 parentheses divided by 1590 parentheses times 1,000.
I keep getting an error. I don't know why.
Well, I'll walk it through with you. Is to do 100, and then
Yeah.
E, and it does the caret and then the parentheses, and then do another parentheses, and then do ln 0.5
Oh, wait.
parentheses.
Two parentheses. Okay, hold on. ln
Yep, two parentheses.
1590.
And then divide by 1590 parentheses times 1,000.
Wait, ln divided by 1590?
ln 0.5 divided by 1590.
Oh, I didn't. Sorry about that.
Okay.
Divided by 1590.
Parenthesis and then times 1,000.
Okay. Gosh, I got the 64.67.
Yeah. And then the last part is, when will the mass be reduced to 30 milligrams? And then so you just put 30 in place of Y. And then we're going to search for T. So that same formula, just now we have 30 for Y. So you divide by 100 to get the E by itself. Did you get that part?
Yeah. Would you take the natural log then for both sides to get rid of the E?
Yeah.
Okay.
Oh, no, what I did was I did the one where you do the natural log 1/2 divided by 1590 T equals natural log 0.3. No, yeah, that's natural log on both sides. Sorry. Yes.
Okay.
Sorry.
It's fine. Oh. I think I did something wrong. So I got 1.7369.
Yeah.
Do you just multiply it by something to get it the decimal point
So
of it? Or?
what I did was I put the natural log 1/2 divided by 1590 into just like a decimal form because it was easier for me.
Oh, wait. Then you have to plug it back into T, huh?
So then, yeah, then it's negative 4.359 times 10 to the negative 410. And then you divide natural log 0.3 divided by that number. And then you get T. So I put that into a decimal form. And then to get T by itself, you divide it over natural log 0.3 divided by that number.
Oh, well, I think I just kept it as natural log. So I have natural log of 0.3 divided by natural log of 0.5.
You're missing the divided by 1590.
Oh my gosh, I am. Wow. Divided by.
Because it's natural log 1/2 divided by 1590 is the actual like number.
Yeah, I just forgot to put it on there.
Oh.
I keep missing things. So then I see why you did that then. What did you get when you divided? You divided ln of 0.5 divided by the 1590 first, right?
Sorry, what?
When to get rid of the ln 0.5 divided by 1590, did you over from the other side? Did you divide that first and
No.
then?
So what you do is you divide the 100 and you get 0.3, and
Yeah.
then you do. I don't know what it's called, but you put the exponent t, and then it's the natural log of this side.
Yeah.
And then what I did is in the calculator, I did natural log 1/2 divided by 1590, and I just used it as a decimal because that was easier for me. Does that make sense?
Okay.
So if you put
So I'm doing that, but I'm getting a decimal of, I think it's just like yours. It's negative 4.35941, all that stuff. But then when I divided over and I put it as ln of 0.3 divided by that number, I get, oh wow, now it worked.
okay.
And what did you guys get? You guys got 2,700.
Yeah, I got 2,762.
61. Did
You
you?
round it up?
Yeah,
Well, in my paper I put 2,761.78 years, but
oh, okay, sweet.
Yeah.
Okay, that's what I got too.
okay. Cool. So that was the last for the extension problems.
On
And now we have a quiz. Because we're lucky that way. And I started doing it, but I'm not sure if I was doing it right, so we'll just do it together. You guys have that pulled up, or?
Yeah.
Okay. So if log A3 equals $sign and log A5 equals pound, rewrite the following expression in terms of $signs and numbers. So the first one was log A15 equals, so that's times. So I did log A, I wrote it out with numbers first. So I did log A3 plus log A5.
Okay.
And I don't know if this is right, so if you guys know the different way. So I did log 3 and log 5, and then I just changed it to numbers. So log A $sign, log A pound.
That makes sense.
Does that make sense to you guys?
Yeah.
Yeah.
I have it written down, so I'll turn it in this time if that's okay, because I already
Okay.
started writing it down. As long as it's right and we all agree on it. Does that look cool though?
Yeah.
Yeah, that looks good.
And then, but if you think of it something different, just let me know. So then the log A of 0.6. So that one is a division. So I did log A 3 divided by 5, which then it expands out to the
Log.
minus.
Yeah, minus.
So then I got log A 3 minus log A 5, so log A $ minus log A pound. Does that make sense to you guys?
Yeah.
Okay.
Did you just on this next one? Did you just use the log A5 3 times, or did you just do it to
I did, yeah, log A 5 to the third power.
Yeah.
And then it would be 3 log A 5. So then this is one I didn't know because it's not really a log A. It's not really log A3, so I think it wouldn't be I put a $ log A pound, but I think it would still be 3 because it's not log, right? Like when we're writing it in the $signs.
Yeah, if it doesn't have the full log, I don't think it'd be. Yeah, you're right. I think it'd just be 3.
3 log A pound.
Yeah.
Does that make sense? Because it's just log A3 is the $sign.
Yes.
Okay. And then the next one was log A 27 divided by 25.
Oh.
So I changed that to the minus. So I did log A 3 to the third minus log A 5 to the second.
Yeah.
And then did the exponent rule where it's 3 log A to the third, or 3 minus 2 log A 5. Does that make sense?
3 log 3 and 2 log. Yeah.
So then it would just be 3 log A $ minus 2 log A pound.
Mhm.
You guys agree with that?
Yeah.
And then last one was log A square root of 45. And I broke that up and I did log A and then 5 times 9. So then I got log A 3 square root 5.
Okay.
Is that how you do it?
Yeah.
So then it's times each other. So I did log A 3 plus log A square root 5.
Would that would be final, right?
Yeah, and then to change it, I did log A $ plus log A, and then again, I didn't know. I did square root pound sign, but it's not exactly the same, so I don't know what to put for that part, you know?
I think you leave it at log A squared 5.
Because
Right.
it's not.
Because it's a different end result in a different number.
Because log A 5 is the pound, but this is log A square root 5, right?
Yeah.
Okay, I'll change that. So like that.
Sorry, I don't have that big. Yeah. That's what I would go with. I don't know about
If you
think
put,
it's right. I don't know. I think that's right.
hold on, I just want to see something real quick.
Yeah, if you have something different, let me know, because I just.
Because I think if you put the log 1/2 times log of 5, it would be the square root or some. I thought it was, but I'm gonna try to see.
What are you saying? Like at the beginning?
Yeah. I'm trying to get it now. Let's see. Yeah. So if you put 1/2 times log of 5, it's the same thing as having log square root of 5.
Sorry, can I see your
So
paper? Or say
I put it on here on the calculator. So if you put log square root of 5 and
okay.
you get that, and then you put 1/2 times log of 5, you get the same thing.
Okay, so now then you'd be right. You were right the first time. My bad. Sorry about that.
So sorry, let me just write this down. So then that would be log A3 and starting out the work, log square root of 5 becomes log A of 5 and 1/2. And then so it would be log A3 plus 1/2 log A5. So then it would be log A $sign plus 1/2 log A pound. Is that what you're saying, Antonio?
Yeah. Yeah. Let me see. Yes.
Okay. Thank you. Forgot that.
I just remembered because I can't remember where, but I knew that in order to get rid of it was a different root, and you just had the 1 over whatever that root was to get rid of that, to simplify it. And I just want to make sure. I couldn't remember for sure.
No, that makes sense. Thank you.
Yeah.
So that was as far as I got ahead for the group quiz. So that this other part we'll have to work together.
This next one's.
Oh my gosh, I know this next one.
Oh, good.
It's just like what I told you with the root, or sorry, the 1/4 to pull that root out of there.
Yeah. Is that all? That's all you would do, right?
Yeah. Well,
because you can't simplify anything else, right?
So I would let me write.
So so what I started was I separate them minus. So I did log 4 square root x5 b6 minus log of 6 or log b to the y7 z16 to separate them out.
No, continue.
Because then so then I got to the 1/4 log b, and then in parentheses x5 b6 minus log b of in parentheses y7 z16.
I don't know.
Okay, so
I don't know if you'd split it up because they gotta be under the same square root.
No, they're not. The first, if you look at it, it's the square root. Oh, they are under the square root. Sorry.
Yeah, I know the way these square roots look, and it's just no. That's just not fun. It's not fun to work with.
So I already done the quiz, the exam, and
wait, you already did the exam?
Yeah, and this problem is extremely similar to one of the exam. I have it right here.
Okay. Walk us through it.
Well, so I was not sure if I did it right is the thing. But so I did what I told you. I pulled out the 1/4 out of it. So I wrote it as 1/4 log b, and then in parentheses, x5 times b6 over y7 times z16. And then I expanded that. So it just blew up on my paper. So it was 1/4 times the log of base b x to the 5th power plus log base b times.
You have to do 1/4 on that one too.
Well, yes, because it's all under the 4th root. All that. So I put the 1/4 outside the parentheses, but I expanded all of that by log b of x5 plus log b of b6 minus log b Oh wait, sorry. So I put that part into parentheses, and then I put minus, and then I start another parentheses, and I put log of b.
So you're doing
log,
1/4 log b to the y to the.
Let me write it out so I can show you guys.
Well, yeah, I just want to clarify.
No, I think
Yeah,
I think I get it.
You have to do the 1/4 log in front of each one, right?
No, just the very front. I'll write it out and I'll show you guys what I.
Well, I just want to make sure I'm doing this.
So if you write it all out, it'd be that mess.
Wait, hold
And
on.
I think my paper's too transparent.
Okay, so 1/4 is on the outside of all of this. So sorry, I'll just write it down. I just want to make sure I get it right. So 1/4 parentheses log a x to the 5th plus log. Sorry, I'm not going to say the subscript on the logs. Okay, and b to the 6th parentheses minus log y to the 7th minus log z to the 16th. Parentheses.
It'd be plus.
I don't mind this bottom part.
Wait. Yeah, you're just missing a few parentheses there. I was confused.
Yeah, you're missing the back parentheses and the other two, and for the brackets.
Oh.
Yeah. So yeah, you take the 1/4 into all of that, but then you have to expand it even more, or sorry, you gotta simplify it.
No, but this is right now.
Yes. Well, let me see. Hold on. Just I didn't really. Yeah, that's right.
Okay.
But you have to make sure that you, I guess with the brackets, is that to just show that 1/4 goes into everything?
I guess I
Into
wouldn't
all
need a
of-
second bracket around B6 then, right?
The what? Oh, I do need that.
So more like
Dang, I
this.
missed
So
one.
1/4 goes.
Yeah, but so that log base b of x5 plus log base b of b6, that's one part, and you want all of that into one parentheses, and then the other part is in one parentheses, but leave the minus sign out of it. Leave that outside of it.
Okay.
Yes. Yeah. And I had to write more parentheses in mine. That's what's gonna be the most confusing part, is the parentheses.
Because now we have to do the 1/5 of all of those, or the.
Well, you don't want to put it back in yet because you want to get rid of the roots.
Yes. So then what do you do? So 1/4, and then it would be so wouldn't it be 5 log x?
I got 5 log base b of x.
Okay. Oh man, this is intense a little bit, huh?
It's not even done yet.
My word. Okay, so then.
Holy cow. So 5 and 6, 7. Yeah.
And then in parentheses x, b, y, and z because they're by themselves now. Okay.
Wait. Oh, So now you want to get rid of that minus. So you would distribute it on the 7 log base b of y, and then also the 16 log base b of c.
So,
And then
then it ends up being minus 7 log by and plus 16 log z.
no, minus 16.
No, plus, because if you're distributing the negative, that becomes negative, and then that becomes positive, right?
You had it as positive?
For that second
No.
one, would you distribute it?
So I had it as positive before because they're multiplying on the bottom.
You're right.
So after you distribute it, it would be negative. So you'd have the -7 and the -16.
Thank you. I missed that part.
And then after that, you can get rid of all the parentheses, except the very one for the 1/4. And then you would put the 1/4 into the first number of all of it, of all of them.
So
you'd
multiply the 1/4 by all.
So that we're still keeping them negative, right, to each other, because then we're going to divide it by each other.
Yeah. So you would have you don't. So it's kind of like having the top part. So the 5 log base b x plus 6 log base b b, that solved on the top, and so it's divided by all the rest. So that's why it's minus and minus.
So at what point are we expanding? We're not putting it back into that form. So could you leave it as the 1/4 times all of that, or do you need to distribute it out into each one?
Well, you gotta simplify it, and if you put it into all of that, you can just simplify it by that.
So you just do 1/4 times 5 times 6 times 7 times 16? Because
yes,
you don't mess with the x's and the b's and all
no.
So,
Yeah, just like you said. Yeah.
Okay, so do you keep it in fraction form?
Yes, you should. Yeah, that's what I did. But you can do whatever.
No, so it'd be 5/4 log b of x, and then three halves, because you simplify it, 3/2 log b of b minus, sorry, I'm slow, guys. Calculators.
And you do want to simplify those two, if you can.
Yeah. So then minus 7/4
log of y.
Y minus
4 log z.
Thank you. 4 log z in parentheses. So does that look? That bottom one.
Yes.
Yeah, but you don't want the parentheses anymore, because you've already distributed out the negative.
Okay, so just.
So
and then
you want
distributed out the 1/4 as well. So you just want to.
So you're saying without parentheses, so.
Yes, just like that. Yeah, but then now you see the second part where it says log base b of b. You would cancel that out because log base b of b would just equal, I think 1. So you would just be left with the 3/2.
So would you put that at the end, or can I just do and the next slide?
I left it there because it goes with that first part. So I just left it where it was.
Let me write it out again so you can.
Oh my gosh.
Like that?
Yes. Yeah, that's what I did.
Okay. We all agree on that answer?
Wait, hold on. Let me see. I'm sorry, I was just checking.
Okay.
Yeah.
And you don't need parentheses to show which side.
Yeah, now I got that.
Okay. So then, next one is Benjamin Franklin gave Boston a gift of about $4,000. This amount grew to $2 million in 20 years or 200 years. What is the interest rate? I think we did one of these. And I hated it. So I think it's this A equals P 1 plus R n over NT. So A is 2 million. P is 4,000. 1 plus, we don't know the rate. And then
no, that's right. For a second. Annually, so it'd be
it'll just be R over 1.
1.
And then raised to the 1 times, and it was 200 years.
Yeah, 200 years.
So then we're going to divide by 4,000 to get that by itself. So 500, 1 plus R over 1 raised to the 200. So I think we do 500 raised to the 1 200ths, right? To get 1 plus R over 1 by itself. Or R plus 1 plus R, because it's not.
Yeah.
Yeah.
I don't need to complicate that. So I got 1.032. I'll just round. 1 plus R minus 1. 31.6%. That can't be right.
Maybe is it 3% point 3 point? No, because you can't get the decimal messed up.
Would you plug that back in again?
Did I plug it back in?
No, I mean when you get the rate, would you plug that back into the equation?
Yeah, let's try it, because I mean it might be a little off since we're rounding, but
I didn't. I'm just keeping the big number because I want to make sure. But
I'll plug it in and see what it would get. Hmm. I don't think that's right because I got like 4 million, not 2 million. Was there any questions about the oven temperature thing?
The what?
The oven temperature. Oh, guys, we did one of these on our. I think we did one of these on our extension problems the first time. The same question. Similar, at least. So what we did was, so we divided by 4,000 to get it by itself. And then I think I did it. I think we're supposed to take the square root of it. Sorry, let me, hold on. Okay. So what we did, so we got 500 plus 1 plus r raised to the 200. And then in our extension problem, we took the 200th root of 500, which is 1.031560847. And then you minus 1 to get r by itself, and it's 0.031560848. And then to get the percentage, then it's just 3 point, and I rounded 3.16. Does that make sense?
Yeah.
You guys get the same answer?
Sorry, what did you get?
3.16%.
that's yeah. Hold on. So on the first one, I got the 0.31 5, but isn't that supposed to be 31.5%?
Yeah.
But
no, because it's
then
0.03, so it's just over 2. So it's 3.156, but I rounded up to 3.116.
oh wait, sorry. Why did I do that? Okay. But then when you plug it back in, does it give you maybe because I just hold on, I gotta do it again.
Yeah,
Okay,
I
yeah,
get
yeah, that's
1999999 rounded up to it's 2 million.
well, I got since I didn't round down, it does give you exactly 2,000.
Okay, so 3.16%.
Yes.
Yes.
Cool. And then the last one is solve log x minus log x minus 1 equals 2.
I think I got this one. So I think you start by subtracting log x minus 1 from both sides.
Subtracting.
Or adding, my bad, adding log x minus 1 to both sides. And then then you could separate it so log 10 of x equals 2, because there's no base, so it's 10. And so it'd be 2 equals log 10 times, right?
Say it again. I got lost what you were saying with log 10.
Right, because it has no base, so wouldn't it be log 10?
I don't think you have to put 10. If it's a thing that's implied, I don't think we have to write it.
Oh, well, yeah, but I'm just saying it because I need it for the, because if you have it simple, if you add x log x minus 1 to both sides, then what you have is log x equals 2 plus log x minus 1, and then you can do it so it because you could make it so you could separate it so 2 equals log 10 or log 10 squared, because that's practically a log itself. That's almost the full log itself. Do you follow me there? It's hard to.
Yeah, I'm gonna work it out and then let's see if we get the same answers.
Okay.
Is that okay if we do it that way?
Yeah. Probably better. Okay, I got
100 over 99.
Yeah, that's what I got too.
Yeah.
So I just did the work like that. It might look different, but if we all got the same answers, I think we're good
Yeah.
for the quiz.
Yeah.
Yeah.
Okay.
That's what I got. Okay, sweet.
So there's just the 4 questions for the quiz. Okay. So I think we're done.
Sweet.
So I'll submit in the both the link for the meeting and the quiz if that's cool with you guys, and then do it too.
Okay.
Okay.
Sounds good.
Cool. Enjoy the rest of your Saturday.
To have
You too.
gotta take that exam today.
I know. Antonio's like ahead of the game. He already did his.
I'm
When
trying to get ahead. I still gotta email my teacher. I'm trying to get ahead for when we're moving on Wednesday.
Yeah,
So-
that's stressful.
And on Tuesday I have we're doing a gender reveal party, so I can't meet at the same time. I can do it anytime, but not at 8. Honestly, hold on. Just one.
Okay.
Ironically, that's what I missed Wednesday for. My sister's gender reveal.
Oh, fun.
So that's at 7:30. So I don't know if you guys can do it before that or if we do it on a different day.
I'm good to do earlier than that.
So I can't. I have my chemistry class.
Okay.
Yeah.
So, I mean, we could do it on a different day, or we could do it even later.
If we do it when I can't do Wednesdays at 8 too. I have to do it like 6 on Wednesdays. If we do
we did it on, is there any way we could do it on on the Monday?
I'm good for Monday.
Yeah.
Because if we can do Monday, I can be there. And then I wasn't sure if you guys wanted to meet Thursday. I think, well, we're going to try to see if we're there by 8 on Thursday. But either way, I think I should have internet access at that point.
Okay.
So I'll just do it off of my phone. I might not be a whole lot of help, but I'll try to help you guys as much as I can.
Okay.
Okay.
Yeah. So how about you send an email out to everyone to see if we're okay to do it Monday?
Yeah, I'll send it on this chat, and then I'll message everyone on text message, and then I'll email my teacher just so she knows as well.
Okay. So we'll just plan on Monday around the same time or at 8?
8 works for me.
Okay. I'll plan on that then, and then Thursday we'll just keep that. So let's see.
Okay.
Okay. All right.
Sounds good.
Sounds good. I'll get this submitted and I'll let you know when it's done. Okay.
Right.
Right.
All right.
Thanks.
Thank you.
Thanks.
Bye.
Bye.